All right, welcome to Calculus. I know you've been enjoying your summer, as I have been too, and part of our summer joy was a homework packet for Calculus. Yes, I do not waste a minute in helping prepare you for the AP Calculus exam, and I hope you've been trying your way through the packet or even being successful on some of the packet. I'm going to provide an answer key in video form so that you can watch the video and do a little bit of learning from the video, and I will break it up into probably 5 videos. It's important that you watch these videos and understand the problems, as our first unit test is going to have minimal instruction time, as it's just a review of pre-calculus. So what I want you to do is not only copy down these processes, but also use this video as a learning tool for you. So let's get on with the answer key. Actually, for length's sake, let's say that this is problems number 1 and 2. Hooray! Time to go back to school. All right, we'll begin the key with problem number 1a, which was given to us as the quantity of 2a squared to the third power all over b. And the purpose here is to simplify it down into a clean expression. So what we can do is we can take the 3, this 3 here, and we can distribute it in using exponent rules. So this first step would bring us 2 to the third, and then a squared to the third, so we can multiply those exponents, and it does not apply to the b. And then if we simplify that down further, what we get is 8a to the 6th over b. Because the question is asking us to write it in the form of c times a to the p, b to the q, what they're wanting us to do is have it so there are no fractions. So what we have here is our c is the 8, and then we have a to the 6th, and b to the -1. And that's our final answer. The way that we get that -1 is what we have is this is b to the first power, and if we move it from the denominator to the numerator, we wind up having b to the negative exponent. So this 1 becomes -1. All right, let's move on to 1b. Okay, 1b, we are given the radical expression 9ab to the third, and that's all in the radicand. The radicand can be converted into an exponent, so we can write this as 9ab cubed, all raised to the 1/2. So remember, we can take that radicand and write it as a fractional exponent. As a quick aside, the idea is if you have this property, we can rewrite it as x to the m over n. And since we're taking the square root, our index is a 2. So that index right there moves to the denominator of our exponent. Distributing that half in, we're going to get 9 to the 1/2, a to the 1/2, and then b to the third to the 1/2. And we can simplify that finally down to 9 to the 1/2 is the same thing as the square root of 9, which is 3. We can't simplify a to the 1/2, and the b, we can simplify it to b to the 3/2. So there's our final answer. Moving on to 1c, what we have is a times the quantity 2 over b all over the quantity 3 over a. And what we can do is we can start simplifying each piece down until we remove all the fractions. So let's focus on the numerator. Our numerator is basically a fraction times a fraction. So what we have is 2a over b. And our denominator is already simplified down to 3 over a. And we know that a fraction divided by a fraction is the same as the fraction times the reciprocal. So what we're going to get is the numerator times the reciprocal of the denominator. And when we multiply this across, we're going to get 2/3 a squared. And that b in the denominator, that was a b to the first. That can become b to the -1, so that it's no longer in the denominator. And we're into that final form that we wanted. Okay, for 1D, we're getting a little bit of a change of pace. What we have is ab minus a over b squared minus b. And what we have here is we don't have exponents that can quite cancel. What we have is kind of a polynomial divided by a polynomial. And oftentimes when I see a polynomial, I think maybe a good move would be to factor the polynomial if we're trying to simplify things. So if I simplify the numerator by factoring, I get a times b minus 1. And we can see that the a times b is ab, and a times 1 is a. If we factor the denominator, what we will get is b times b minus 1. And after factoring those two polynomials, we see that we have a common term in the numerator and the denominator, and that allows us to cancel out that common term and reduce the fraction to a over b. And this is pretty simplified, but to fit within the instructions, we should write this as a b to the -1, because again, that b in the denominator can be turned into b to the -1. Okay, moving on to 1e, what we have is a to the -1 over b to the -1 times the square root of a. And the first thing I want to do is get rid of the radical, because I prefer dealing with number exponents rather than the radical symbol. So we can rewrite that as a to the 1/2. Then the next thing I'll do is, ideally I want to move everything to the numerator, because we don't want any fractions. So in doing that, what I will have is a to the -1 stays in the numerator. When I move the b up to the numerator, the sign of the exponent changes. And when I move the denominator a to the numerator, the sign will change again. And so we have these three terms, and we can combine our a terms. So this a times this a, if you remember the exponent property, a to the m, a to the n is equal to a to the m plus n. So if we apply that property, our a's will combine to a to the -1 plus -1/2, and our b stays by itself. And -1 plus -1/2 is a to the -3/2 b. And we don't need to write the power of 1 up there, but if we want to, we can. All right, the last one, 1f. What we have is a to the 2/3 over b to the 1/2, and that is all being raised to the second power, and then we have b to the 3/2 over a to the 1/2. And the first thing I'm going to do is I'm going to distribute the 2 in. So what we will wind up having is a to the 4/3, because 2/3 times 2 is 4/3, and b to the 2/2. So we've simply multiplied that exponent in, and we'll leave the second fraction as is. Okay, from here what we want to do is start to combine terms, and we'll start with the b terms because those are the easy terms. We have 3/2 on top and 2/2 on bottom, so we can subtract out 2/2 and we're left with b to the 1/2 on top. And the property that I was applying there is if we have b to the m over b to the n, we can go b to the m minus n. So in this case, our m was 3/2 and our n was 2/2. So 3/2 minus 2/2 is 1/2. We can apply the same property on the a, and we'd get a to the whatever 4/3 minus 1/2 is. And with a little bit of manipulation, we find that to be 4/3 minus 1/2 is 5/6. There we go. Man, this rocks. All right, for problem 2, we're being asked to simplify fractions, and this will require us to do some factoring and probably some combining of various fractions. So in 2a, what we have is, let's get the right tool here, x to the 3rd minus 9x all over x squared minus 7x plus 12. And it looks again like we have a polynomial over a polynomial. So very quickly we can go about factoring out the x in the numerator, and we get x squared minus 9. And in the denominator, factoring that out, we can get, looks like x minus 4 times x minus 3. So a little bit of that factoring coming back to us. So the next thing we can do is we can actually factor that x squared minus 9 a little bit further into, it looks like a difference of squares, so we can factor that to x minus 3, x plus 3. And our denominator stays the same as x minus 4 over x minus 3. Now that we've factored out this rational expression, we can cancel like terms out of the numerator and the denominator. So our x minus 3 cancels out of top and bottom, and we're left with the final simplified answer of x times x plus 3 over x minus 4. Alright, 2b is pretty similar in the fact that it's a rational function, which is a polynomial divided by a polynomial. So we can take this numerator divided by the denominator, and we can try to start factoring it. That's messy. Minus 2x. Okay, the numerator, let's see, factors into x minus 4 times x plus 2. And the denominator, we can pull an x out, so I'll do that first. We're left with x squared plus x minus 2. Factoring the denominator further, we get x times x plus 2 times x minus 1. And our numerator stays unchanged. Then we go about canceling like terms. And our x plus 2 exists in top and bottom, so we'll cancel those out, and we're left with x minus 4 all over x times x minus 1. And there's our simplified rational expression. All right, with 2c, we're changing it up a little bit. We've got a variety of fractions here, and we're wanting to simplify it all down. So let's start by making sure each piece has the same denominator. And in this case, finding that denominator, what I can find is that my LCD for all 4 of the fractions is 25x squared. So my first fraction, 1 over x, in order to make the denominator 25x squared, I need to multiply the top and bottom by 25x. And that gives me 25x squared in the denominator. To make my second fraction have a denominator of 25x squared, I'm going to need to multiply the top and bottom by 5x squared, because 5x squared times 5 is 25x squared. The bottom fraction, it looks like I'll need to multiply both top and bottom by 25. And the bottom right fraction, 1/25, I'll need to multiply top and bottom by x squared. Now that all of my fractions have the common denominator, I can start combining them. So my numerator combines into 25x minus 5x squared all over 25x squared, and my denominator becomes 25 minus x squared all over 25x squared. Now what I have is a fraction divided by a fraction. So we can do the division trick where we take the numerator and multiply it by the reciprocal of the denominator. So let's slide this up over here and take the numerator and multiply it by the reciprocal of the denominator. And when we do that, these two terms cancel. And we're left with 25x minus 5x squared over 25 minus x squared. And we're still not completely done yet, because now what we have is a rational function where we can probably cancel terms out of the top and bottom. So we're going to need to factor the numerator and factor the denominator. So the numerator factors to 5x times 5 minus x. Let's check that out real quick. 5x times 5 is 25x, and 5x times x is 5x squared. Okay, moving to the denominator, this looks like a difference of squares, which factors to 5 plus x times 5 minus x. And now we see that the terms cancel, and we're left with a final answer of 5x over 5 plus x. Here we go. Final answer in simplified form. Now, the approach that I took is not the only approach that can be done in simplifying these. There are shortcutting methods that some people tend to use. but what I've shown here will work for the majority of problems that look like this. All right, 2D. This is similar to the last one in the sense that we have fractions, multiple fractions working together. The first thing is that x to the negative 2, we could write it as 1 over x squared. So we see that fraction there. And we can do the same thing in the denominator where we have 3 plus 1 over x. If we find our least common denominator, then we can start to rewrite this as a series of fractions. And our least common denominator in this case is x squared. So I'm going to write this as 9x squared over x squared minus 1 over x squared divided by 3x squared over x squared plus x over x squared. If we're able to see that, then we can move on to the next step where we combine our fractions. Our numerator becomes 9x squared minus 1 all over x squared, and our denominator becomes 3x squared plus x all over x squared. If we use our trick of multiplying the numerator times the reciprocal of the denominator, the x squareds cancel out and we're left with 9x squared minus 1 over 3x squared plus x. And now we're at a rational function and we can factor the numerator and the denominator to see if terms cancel. So the numerator factors to 3x minus 1 times 3x plus 1. And the denominator factors to x times 3x plus 1. And we see that there is a term which cancels out, and we arrive at a final simplified answer of 3x minus 1 all over x. Some people might take this a little bit further and simplify this to be 3 minus 1 over x. Because you can see the 3x over x, those x's cancel to give you 3, and then the 1 over x becomes 1 over x. So, in truth, I would say that this one in black is a more simplified answer. Alright, that's problem 1 and 2. Stay tuned for future videos walking us through more problems within the summer homework packet.